So this is Lab 1 that I'm presenting here. I'm Krish Patel. This is Lab 1 for Physics 2212 that I am recording here for you guys today. So the introduction of the lab, utilization of a piece of tape in order to observe the electron transfer between the respective surfaces and to calculate the electrons transferred between the respective surfaces. To the right here is the figure 4 from the provided instructions, and it shows the original position of the tape B, and will also show where tape A will be in respective when we're trying to measure the distance or fluctuation of tape B due to the charge and its effect. Now the involved principles here, we have Newton's second law, which would be the force equal to the mass force of gravity, in this case, which would equal the mass times acceleration. In this case, the mass would be the mass of the tape, which we will go into further on later in the experiment in the report. And acceleration would be acceleration due to gravity, which obviously would be negative 9.8 meters per second squared. We'll also be using Coulomb's law here to determine the electricity force, or force by electricity. The formula is to the right with a 1 over pi e naught, and then the q squared over the distance squared, or d, in the case of that formula, which is grabbed from the provided text. So results coverage, to the right is the diagram shown, the intended result shown by the report. In this case, we were able to replicate that. So what exactly happened? The charge tapes, or the like charge repelled, is both would be noted to be positive, and we know that like charges repel. In this case, the calculated charge with the Coulomb's constant was 1.52 e to the negative 8. So getting into the experiment here, a neutral piece of the tape was placed on a solid flat surface, and then another tape, which was assumed to have neutral charge, was also utilized. The initial tape, which was present on the surface, was quickly peeled up and to leave the base tape. Assuming there was a transfer of electrons, the U-tape was held near other objects and the piece of tape to determine the distance of travel on the other piece of tape, which we take into the calculation. The distance, or says it at the bottom here, the distance was taken into consideration during the calculation. Now the qualitative results from the experimentation, I learned that the U-tape was not attracted to the tape hanging, likely due to the ideas that like charges repel. In this case, as we mentioned prior, that they both were positive like charges, which would support the idea that the like charges are repelling. However, the U-tape was attracted to objects that would be deemed neutral on the desk, such as a pen that I had laying on the desk. Now, calculations here, the mass of the tape is shown, the length of the tape is shown, the width of the tape is shown, the floating distance, the force, and then over here to the right here, we have force of gravity calculation, which I was talking about earlier. Obviously, we have here the mass of the tape, and then the constant 9.81, and then the Newton's calculated force here. Now, I wasn't able to bring in the Coulomb's law charge, but here's the charge calculation using Coulomb's law, which equaled that 1.52 e to the negative 8, as we discussed prior. Closed group code, those are all the constants that were mentioned right here, replicated into my closed group code. The calculation code will be on the next slide. So the calculation code here, you have the force of gravity calculation, and then you have the force electric force, and then the tape charge and electron count charge code. The discussion section, the charges were not completely neutral during experimentation as possible, and then unequal charges present on the tapes as well as charge issues due to the fact that I handled the tape. The what if section here, would the tape have been attracted if one was somehow not affected by my handling and was rather handled with an insulator? And then another, I feel it is important to take myself out of the equation. Unfortunately, due to the design of the experiment, I was unable to do so. However, if I were to do the experiment again, I would take that into account. That's all I have for this report. Thank you, guys.